Right, well, make a start. I think that clock is, yeah, that clock's slow. So, I'm Marc Gravell. I'm here to talk about gRPC and what's happening both now and what's coming up in .NET Core 3. And we'll see how it goes. So just to introduce myself, to kind of see where I'm kind of coming from on this. So I work in the architecture team at Stack Overflow. Mostly my kind of key role is kind of anything to do with kind of networking, talking between services, getting data in and out. And I kind of, as part of that, I've become involved in a kind of a range of libraries like Protobuf .NET, Dapper, SE Redis, and a whole range of kind of other things that kind of have anything to do with either networking or kind of metaprogramming, which are kind of two big interests. And you're going to see how those kind of tie into all the things I've been looking at in gRPC. But that's who I am. And in both on email, Twitter, or outside, any kind of questions, feel free to ping me. Yeah, I love talking about this stuff. Right, now, I took a poll earlier after I'd done my timings and realized I've kind of got about 3 hours of content and 45 minutes. So I took a poll, and they suggested we should just kind of lock the doors and just keep going. Now, if kind of Trump and Brexit have taught me two things, it's that democracy isn't all it's cracked up to be. So we should probably just go with option one, and I'll try and keep things kind of slim. So my intent today isn't to kind of teach you. If you come out this session, you're not going to come out thinking, yes, I know how to use gRPC in every detail, I understand every step in there. That's not what this is about. This is just kind of to whet your appetite and kind of give you an idea of what you can do, and hopefully get you excited to kind of explore it, play with it, kind of plan to kind of work with it. So what we're going to look at today, what the hell is gRPC, and why would you ever want to use it? How would you use it today? Without any of the .NET Core 3 stuff, what can I do today? And what's the strengths and weaknesses of that? Then what's coming up in .NET Core 3? So that's kind of what's the good stuff there that kind of Steve's hinted at, and other people have mentioned a lot today. In fact, in the talk next door right now, one of the things they're going to talk about is gRPC. It's obviously a kind of a big topic at the moment for what's happening in .NET Core 3. There's other things that are important in .NET Core 3, but gRPC is definitely up there. Then there's a part two of that, which is not the Microsoft bit. So Microsoft are doing a whole lot of stuff, but there's also some other really cool things that are coming up in the gRPC space, and I'll kind of talk about some of those as well. And there we go. So, what is gRPC and why would I care? Everything is connected these days. I don't care whether that's microservices, macroservices, or the light in your toilet. Everything is talking. I can't change the temperature on my thermostat without my phone now. So everything's connected, and as developers, we're spending more and more of our time talking from one system to another, and writing complex code for that, or even just anything more than the minimal amount of code, starts getting dangerous and brittle, and you spend time writing things that aren't interesting and aren't actually solving your business problem. So gRPC is so it's an RPC stack by Google, and one of the key things about it is it's kind of platform independent. It's from the ground up. So it's designed to be based on kind of the protocol buffers data format, serialization format. If you're not familiar with it, just think JSON or XML, but in binary and done in a way that's efficient and designed to be kind of platform independent. For example, if you ask James Newton-King or Kevin Montrose about how fun it is formatting dates in JSON, they'll just cry and walk away. Some of these specifications are only specifications kind of in the kind of guidelines sense of the word. Obviously, if you're talking to some services like Google, you'll have to use gRPC because that's what the protocol says you're going to use. But it's a good choice if you're just writing systems and you don't want to spend all your time writing complex network code. I mean, I write libraries like SE Redis that deal with the socket layer. You don't want to be writing that. Most people don't enjoy that stuff. They want to be solving a business thing. So you don't. If somebody else has solved all those problems for you, great, use it. But like I say, normally it's used with Protobuf, so really to kind of understand gRPC in the traditional sense, you also need to understand Protobuf. That's not necessarily the case kind of going forward, but I'll give a very, very brief overview of it. So like I said, it's a binary serialization protocol designed and used by Google. There is also a JSON version of Protobuf, but I kind of don't talk about that. It's kind of a, yeah. I'm a networking guy, and I like the binary thing. The JSON, to me, it's kind of why, but whatever. Again, it's open source, platform independent, and it's been specifically designed to be low CPU and low bandwidth. So if you've ever looked at kind of JSON or XML, they're very, very verbose. It's constantly sending the same field headers. I mean, if you're sending a JSON object or an XML object of 200 record objects, you've got imagine XML. You've got /customer and /customer ID, and it just goes on and on and on. If you've got XML namespaces, yeah, you can compress some of that, but why? Binary serialization protocols save a lot of both processing and bandwidth, and just make everything nice and shiny. The other nice thing is version tolerance. So if you've ever fought with binary format, never use binary formatter now. It's 2019. If you're using data table or you're using binary formatter, please stop. But yeah, what's really, really useful from a developer perspective is it's been designed to be version tolerant from the outset, and it works really well at it. There are some things you can't do, but yeah. Most things work fine if you're just kind of adding fields. That's great. The one that you can't do, I guess it's the same as JSON. If you have in a JSON, if you have something called name one day and it means one thing, and then you obsolete that field, and then in a year's time you come back and you create a new field called name and it means something completely different, then yeah, your system's going to go mad if you've got old data and you try loading it in the new def. The same thing happens in protocol buffers, so just don't do that. It really is that simple. So why would you use, how would you use gRPC today? So I could have done slides, but I thought let's be brave and go with demo, which does mean I need to get out of PowerPoint. Blah, blah, blah. So bear with me. Please stop while I fight with the powers. No. This one. Die, PowerPoint, die. Hey, there we go. And it's an improvement. There we go. All right, can you read that? Ish. I'll settle for ish. Right, so I've got a ton of stuff here, and I'm totally cheating. This is just the GitHub repo, which means that all of this code is available for you to play with and now if you're interested in it. So I'm not going to write code from scratch because I don't have the time for that. But what we can do is explore stuff. So I have got a myriad of solutions here. And one of the ones I've got here is a gRPC solution, which I will just close all of these so that we're not getting confused. Close all documents. So I've got, in this gRPC folder, 3 projects, client, server, and shared. And the shared one is just, so in gRPC at the moment, gRPC is based on Protobuf, and Protobuf in the Google way is very contract first. And what I mean by that is they like these .proto schemas. So that's just a language where you can write some kind of definition. Let me get rid of this window down here. That basically says, I have some data. So I've got this message that's a multiply request. And a response that's a multiply result, because obviously computers, you aren't very good at multiplying things, so you might need to send it off to a remote server to multiply 2 numbers together to get the result back. This is, maybe get some kind of ML thing going on over here. So you formally define your contracts, and you kind of need to give them. The important bit is these numbers on the right. So that let me just zoom in a bit actually, because that's not very visible. There we go. How's that? Big enough? So we've got the names here, X and Y. That is what you might use in your code. But the computer isn't interested in those. The computer only sees the numbers on the right, the 1 and the 2. And so Protobuf doesn't ever send names. It's just numeric fields. And it kind of keeps things nice and dense. And the other nice thing you can do, so that's kind of defining contract, same as you might in C#, here's a class. But the other interesting thing you can do, which is where we tie into gRPC, I just need to change the zoom down a bit, is define services. So here I've defined a calculator service where I've got an RPC call called multiply that takes a request and returns a result. And then in that project, I have some magic, which is the gRPC.tools package here, and a whole bunch of other refs. And what that means is when I build that, a whole lot of stuff happens in the build chain, and I've got a client and server here that reference them. So if I go to the server, you'll see in here, there's no classes called this thing here, my calculator, which I think was the one that came from here. Oh no, that's the client. Where is it? Sorry, I've lost my place. There you go, multiply request. I mean, those aren't defined anywhere. If I kind of zoom into them, we find over, if I can see the path there, it's actually generated in the obj directory. You can't see it there, the font's too small, but that's way off in the kind of the generated build output. So behind the scenes, the tooling just generates this ton of code that just goes on and on and on forever, because obviously you need 16 pages of text to multiply two numbers. You can tell I'm a cynic. So we get that, and that can be used by the client and server. So how might we implement a multiplication service? So again, as part of all that emitted code, it generates a base class, calculator base, and some methods that I might override. So I can override a multiply method here that, again, was generated by that tooling, and I can tell myself that I'm actually doing it, and do the work on the server to multiply two numbers, and then finally return a task of the result. And at the client, I could do something very similar. So I can spin up a channel. I didn't show actually hosting that. So in my program in the server, I'm just going to create a new server object here, tell it to bind to this service, which is an instance of my calculator, and that's it. The tooling takes care of everything, and I just run it. And then in the client, just spin up a channel that works like an HTTP client or anything else like that. Ask for the client on that channel, and I can then give it a request object and a response object. And then hopefully, if I just comment out the code here, what I can then do, if I do run the server, and this is running in .NET Core 3, but this isn't using any of the new stuff. A bit of a small font there, but you can see they kind of spoke to each other. It's got the replies, and the client, it all just worked. And it's simple as that. So we're not using any of the new stuff here. This is how you might use gRPC with Google stuff. It wasn't all that challenging, but there was a whole load of kind of messy steps in the way. But if I go back to the PowerPoint, and please work. Here we go. Blah, blah, blah. I haven't figured out how to get PowerPoint to resume at the right place, so we'll just... So there are a couple of things there. I'm not going to cover all of these, but you can see we kind of got to the point of kind of setting up a basic project. We had the .proto schema, and they don't have to be simple. The ones there, that was really a very basic .proto profile. But it doesn't just have to be one object. They can contain kind of entire trees of objects. So you could have, there's something called repeated, which is like list. So you could have a customer search result that has a repeated customer, for example, and a customer could have a repeated order, and it goes on and on and on. It can be as complex as you like, as long as it's a tree, not a graph, if you know what I mean by that. So like XML, it always expands downwards. You can't have kind of self-referential things. Protobuf doesn't support that. But yeah, you can have some very, very complex systems. And it kind of generates it gets hold of a whole lot of things. Oh, one thing I didn't show that's very important and kind of ties into a lot of the stuff that Steve was talking about earlier. If I just get out of there and switch back to the thing here, one of the things that it's very, very powerful that it supports is cancellation over the wire. When I made my request in the client here, I didn't pass any options. But in the, my font there is way too small. In the overloads, what I can do, I can pass in an options object. And one of the parameters on there is a cancellation token. And if I give a cancellation token to the client, in the thing that the server gets, you can actually get that cancellation token, and if it becomes cancelled at the client, it will propagate that cancellation to the server, which means if you're then at the server, you're then chaining that down to your SQL calls or your HTTP calls from your server to other microservices. You can get proper cancellation flow all throughout your system, and that's kind of really, really powerful, and that again, it's something that's really, really hard to write into systems if you're doing them from scratch. And the other thing that gRPC offers that is kind of quite far outside of the what you might do if you're doing something yourself is streaming. gRPC has the concept of a stream, and that isn't just like a set of data. If you were going to do a set of data, you'd use the repeated thing, which is like a list. So you'd return one result that happens to have multiple things inside it. What you can do instead in gRPC is a stream, which is something that happens over time. It's kind of disconnected. So that might be, for example, you're writing a messaging service. You might have chat events that come in over time as different people say things. So then you don't have to implement any kind of polling system. So in the example here, I'm going to subscribe to a time service. I can get the server to send me a message every 5 seconds to tell me what the time is, and then every 5 seconds the server will send it and the client will receive it. And that it actually does support streaming in both directions, so you can get client streaming, server streaming, or duplex streaming, where the two streams are completely disconnected from each other. The client could send 200 messages, the server could send 5 at completely different times, and there's no relation between request and response. The only problem is, in terms of .NET terms, it's a pretty horrible API to do that. I've got a streaming base here, and it's not that bad. What I'm doing here is I'm going to I'm going to await 5 seconds every time. I'm just going to do this 5 seconds, and then every time I'm going to send a response. It works, but it's kind of backwards to kind of what how I can normally think about things. And in particular, the client and the server get very, very different APIs here. So the client has something very, very different, which is what I commented out here. Again, you can use it, but it's kind of like writing your manual for each thing. There's a bit of a story there. They tried to implement the IEnumerability using the RX extensions, and then RX got the API wrong, and they're trying to fix it. But what you can do there then, if I just save that, again run the client and the server, this time with the streaming, run. So now, every 5 seconds, the server's just going to drip another thing into the feed. You can't really see it there, but you can see the lines appearing as the server just does another await, send me a result. And you can kind of see how you might do that with any kind of messaging system. And you've had to write very little code there to get kind of full streaming. So that's gRPC streaming. And I wish there was a resume from this slide. Let me just blah, 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 blah. Shift F5. Thank you, Steve. I'm learning things. Becoming a better person. I didn't cover security and auth. They exist. You would expect them to. Yeah. So how is that all implemented under the hood? So we've got there's some generated code, which is all that vomit that the tooling spat out, and that references a Google library called gRPC Core API. And there's another library, gRPC Core, And that is basically a wrapper around some native libraries, in this case, it's the HTTP2, which means that we're paying all the problems that kind of come with kind of native binaries there. But historically, that's been kind of what's available. Obviously, native binaries make deployment a bit hard, and there's all kinds of kind of p-invoke overheads and things going on there. But it works. It's a really good solution, and you can use it now today. I think it's on .NET 4.6.1 and above. It's a good solution. I think it's going to get better. That's kind of the takeaway for me. So strengths and weaknesses. There is that DSL. That's great for cross-platform because it means that once I've got that DSL, I know that what I type in that DSL is going to work fine. And anybody who says they've Rust got a Protobuf or Go, it's just going to work. Problems, it's a bit of a nuisance for doing something simple. And the tooling is a bit awkward. It can take quite a bit of effort to get the IDE working properly with kind of the generators and things. There are command line tools you can use as well. There's lots of ways of getting it all working, but it's just a bit messy. But for the .NET purposes, the code gen at the moment, and I don't think it's going to change, is C# only and Proto 3 only. There's kind of two variants of the Proto DSL, and the tooling that the Google ship only supports Proto 3. Which is a bit of a problem because quite a few of the Google templates are Proto 2, including the descriptor Proto, which is what defines the actual Proto format, so you can't even self-host it. The API, this is the way I look at it, is Google have written classical Protobuf and classical gRPC that just happen to be in C#. That isn't my kind of style of thinking about things. I like things to be kind of classic kind of .NET that happen to be using gRPC or Protobuf, so that you get the flavor of .NET rather than the flavor of kind of that Google API. And that, I think, is kind of where I have some problems with it myself. But that can actually be a strength, to their credit. The one advantage of that is that if you're used to using Protobuf or gRPC, then you're going to be familiar with it on Rust, and you're going to be familiar with it on Go, and you're going to be familiar with it on Java, and you're going to be familiar with it on C#. So it's kind of swings and roundabouts. It depends on kind of what you're likely to be doing. Obviously, one problem, the native unmanaged problem, and it doesn't make use of any of those features. And the generated code, it's verbose. We saw the code there. Restrictive. There's different implementations on the client and server. You can't really kind of iterate on it. It is what that format is. Yeah. And the streaming API is, yeah, I have opinions. It's perfectly usable. It really is. You can do stuff with it today. You'll have to write a lot of boilerplate, basically, to make sure that you dispose things correctly and iterate it in the right way. It doesn't make it easy, but you can use it. It's fine. So, why is everyone talking about gRPC in the context of .NET Core 3? So, the point here is that Microsoft are writing new libraries that work with everything that I've shown so far, all the kind of the existing mechanisms, but in managed code. So this doesn't change the API at all, but it changes what's going on underneath. So in particular, that means there's new client bindings there that are using HTTP client, with the HTTP client in .NET Core 3 now becoming HTTP2 aware, which is gRPC is built on HTTP2. That's kind of a prerequisite. And the other thing is server bindings for Kestrel, so ASP.NET Core. Kestrel is a really good server. You've seen Ben showing the Tech Empower things on there earlier. It's a really good, solid piece of code now. It would be really nice to use that and not have to use CHTTP2 as the server implementation. So what we've got, this is what we have today, and that bit in red is the native library. But at the client, we get the whole new stack here, which only, at the moment it references the core, but in the next preview, it should reference just the core API, so it won't have a reference on the native libs. And the same with the server. So that means that if you're writing a client, you just ship that bit on the left, and if you're writing a server, you just ship that bit on the right, and you haven't shipped the native library. You don't have that native library in your distribution. You haven't got to worry about all the pinvoke or the usual problems with native libraries, and everything is good. So how would we use that? So let's switch back to Visual Studio and fight the... Hey, there we go. So I've got another project here, which is the .NET client and server. And these are basically kind of the same code with some differences. I haven't bothered with a new shared example for this because it's just referencing the same one because nothing's changed in that middle bit. They're still referencing the same definitions and the same core API thing. So I'm just kind of referencing that. So how would we set up a server? So this is a regular Kestrel server here in NetCore 3. And what I'm doing is I'm using the web host API. And importantly, here I'm turning on HTTP2. That's kind of obviously required. And that's largely the only change there, web host and HTTP2. And then in the startup, blah, 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 we just added a line here saying, let me increase the zoom. Can I type in a custom number? Let's try 300. Is that better? So I'm using services add gRPC, and that hooks it. This is all the stuff that James Newton King and the kind of team are kind of working on there. So that hooks in all the bindings to kind of get gRPC up and working. It isn't much work, as you can see. And then the only other bit you need to do is say, I want to map a service. And that's pretty much exactly the same services that we wrote last time. Nothing's changed, except the one nice thing. So yeah, like I said, these are exactly the same as we had before, exactly the same ugly code for the async API. There is one change that you get for free, which is that if your thing takes an whatever, doesn't matter what it is, then you get the usual dependency injection that you get from ASP.NET. That just works perfectly. So your services, you can hook your own services into the usual provider and DI tooling that you get from ASP.NET. So let's change out to command line, because all the best demos are command line demos. I'm not a UI person. They don't trust me with those things. Was that me? Don't think that was me. Blah, blah, blah. DN server and .NET run. .NET gRPC, DN client. Oh, I didn't actually show the client code, did I? That would be a good idea. So again, the client, virtually identical. That's a bit, that font's a bit big now. Let's try 200 again, so we see a bit more. The only difference is that instead of setting up a channel, we're now setting up an HTTP client. And Steve, if you want to know, I'm probably not doing it the right way there. There's all some kind of rules about disposing HTTP client. If you want to know more about that, speak to this man. But don't at me. But there's one other thing we need to do. Just because I'm not dealing with auth for this demo, because nobody wants to watch me setting up certificates for 2 hours, I need to set on a flag to tell the implementation to allow HTTP2 without TLS. It doesn't want to do that by default. So that's what that line in above here is doing. It's just saying, yes, I know I'm being an idiot. It's kind of the correct way of pronouncing that line. In real code, you'd obviously not do that. So as you can see here, here's my Kestrel server running. And I don't know if you can see this, but it's recognized there that there's a gRPC method multiply on the hyper.calculator. That's a unary operation. That means it's request in, request out is unary. And then I can hopefully .NET run here.
You're in select mode. So that might have...
I'm in what, sorry?
You're in select
Hey, thank you. You are correct. Thank you, sir. As you can see, and the client, again, is doing the streaming thing on the left. And the server definitely got replies. Things happened. Not a lot of changes to our code. So this is actually quite nice if you have existing gRPC code, because migrating to gRPC on .NET Core 3 is going to be very, very little work. It's just changing from channel to HTTP client. And in the server, it just means instead of creating Google's server object, you're setting up Kestrel and running those 2 lines, add gRPC, and yeah. So it's a very, very easy migration if you're already using gRPC. And if you're not already using gRPC, it isn't all that scary. And as I said, kind of these projects are on GitHub. There's a lot of kind of demos on kind of how to get started with this stuff. So let's see if Steve is right. Shift F5, you say. We can do this. Hey! Thank you. So what we should have seen, setting up a server in Kestrel, yes. Setting up a client with HTTP client. Everything else stayed the same. The only thing is less unmanaged code. In that build, like I say, that did ship the native binary just because of how the references are at the moment. They're fixing that for the next build, I think. But because everything stayed the same, a lot of the other problems that I have with it are kind of still there. Excuse me. So, what do we have today? We've got a .proto schema, and from that you can get your kind of generated code that happens to talk Protobuf, and then with that you can talk to the gRPC kind of core APIs. Now, what I want to talk to next is what else are we going to have? What else can we do with this? I kind of feel like that we can do things to clean up this API and make it more conducive to kind of most .NET developers, or at least most. I'm opinionated on code, and maybe I'm just kind of doing things that kind of work for the way I work, but it seems to kind of work well with people. So I've been playing with some new tooling. So I'm kind of the main author of Protobuf.net, which is a non-Google implementation of Google's protocol buffer specification. The key defining feature of it is that it kind of focuses on looking at things in a very code-first way. So instead of starting with a .proto schema, you'd start with just your code and maybe kind of attribute things. You can get from your code back to a .proto schema if you want. That's nice. So I'm writing some new tooling looking at gRPC that works either against the old unmanaged bindings or that works against the new managed bindings for both client and server that can use Protobuf.net, although I'm trying to make that pluggable if you want to use kind of other transports, other kind of serializers. Maybe you have payloads in those other in the kind of the older, the official Google Protobuf tooling. In fact, I saw somebody the other day using message pack for the serializer, which to me kind of gRPC, I normally think Protobuf, but I guess once you've kind of got the payload, it doesn't really matter what it's, as long as both ends know what they're expecting. It does, I guess, if they both agree, fine. But what I'm trying to do is reimagine the API surface of the services kind of completely. To kind of support better the code-first style rather than the contract-first style. Although, again, if you want to start with a .proto schema and kind of generate code, great. And solve some other problems there as well. So the tooling that I've got for Protobuf, for Protobuf.net, already supports both Proto 2 and Proto 3. So we can kind of exploit that and say, hey, now we can use Proto 2 with gRPC, which we couldn't do with the official Google libraries, and not be limited to C#. It sounds a lot like something else. Anyone here remember WCF, or still using WCF? So if you think of WCF, you'd declare your data contracts, and you might mark your data members, and then you'd create some service contracts as interfaces, and you'd mark the service contract and the operation contracts on the methods, and everything's grand. WCF has some bits it's a lot of complexities in WCF. So I'm just talking about the kind of the simple bits, kind of the API surface of WCF, not all the 17,000 ways of configuring it with a fault tolerance and distributed transactions and, you know, it's still going to be gRPC and subject to what gRPC is physically capable of. I'm just kind of talking about the API surface. So what does that mean? Maybe we could start with some code first, .NET types, and then have a miracle happen of metaprogramming with some external serializer that's got nothing to do with the kind of the Google bit, so you've got no kind of dependencies, and have that talk to gRPC core API, and then have underneath that, we don't care. It could be the managed HTTP client, it could be the managed Kestrel server, or it could be the unmanaged native CHTP2. Not our problem. Our code won't care. It'll work. You know, as we saw, the same code works against either transport. So, how could we do that? If only there were a demo. So, what I want to do is find my mouse. Where's my mouse gone? It's because I haven't pressed escape in the right place. Oh, this could get scary. There you go. I have a mouse again. There we go. So let's close all windows again, because I'm already confused. Window, close all documents. Don't save. I have no idea what that was. So, in a reimagined version of this, I've got a very, very similar setup now, but let's say that my contract now looked a bit more like this. So there is no .proto, and my data is just this. So it's a class with properties that have numbers against them. They need to have the numbers, because Protobuf only talks numbers, can't talk names. And you'll notice that I'm using data contract. I could also have used Protobuf's, got a separate set of attributes. That's good for kind of more fine-grained control. But if for some reason you feel that your services shouldn't have external dependencies, that can work fine. And the other thing is, here I've got a service. And I think you can all agree that that's a very, well, let me zoom in a bit. Let's try 300. So here I've got an interface which maps to the hyper.calculator service, which is what the name kind of worked out as previously. And I've got a method called multiply async that takes a multiply request and returns an async multiply result. In this case, I'm using value task, although it could be synchronous, a blocking call if you want, or return task. It'll just work. And you'll also notice that I've used the C# convention there, kind of using the async suffix. And the library kind of just will figure out that we don't really want that. So what might a server look like? So we've got exactly the same kind of thing here. Nothing's changed in the program file. The only thing that's different is in the startup, instead of using add gRPC, I've used add code first gRPC. And then down here, I've got, again, my services. So let's go to my calculator. And here it is. Very, very similar. Multiply two numbers and return the value task of them. In fact, one of the main reason I'm using value task there in terms of instead of task is that in this case, you might think the client will probably always be asynchronous. The server, depending on what it's doing, it might be synchronous, it might not be synchronous. So I kind of feel like value tasks kind of a reasonable compromise there. But the library will work with any of them. It'll be fine. But this is very idiomatic. There's no kind of craziness kind of going on here. And hopefully, if I go to the client, again, we've created I'm trying to pick the right font size as a challenge. 250, let's try 250. How's that? Work for people? So I've kind of wrapped up the bit to turn on non-TLS support, just to make that a bit less ugly. So that's all that does, is turn off the TLS demand. And then I've said, from an HTTP client, create me a gRPC service on that interface. And there's kind of no client, no other client code on there, just the library can go away and do things just like WCF might. And if we do that, blah, 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 cd pbnet, cd, nope, wrong folder. Server C#. Let's run the server on the left just to show variety. So the server's spun up on the left, and hopefully our client will start running on the right. Well, it's a different example on there, different setup. But it ran a multiplication, and it returned a multiplication, and now it's returning times as they stream back from the server. So I didn't actually show the server, the timing part. Come on, show me another time. There you go, it is working. Right, let me just have a look at the server. The server isn't... so I said the streaming API was kind of funky. What we've got here now for the time service is something that returns async enumerable. And now we can use a while for each. So this is a new feature in C# vNext. Is it 8 or preview? I don't know. But async enumerators is kind of a big thing. 'Cause, async and enumerable, at the moment you can have async and discrete or enumerable. Async enumerable kind of whacks those two things together, allowing you to do for each loops over a source where the things can come in over time. It's exactly what we're doing here. It's a streaming service. So and all we're doing is awaiting something and then yield return, just like you might in a iterator block normally. So to look at the client on that, where's the client? All the client does is, instead of doing for each something, it does await for each, and that is how you consume an asynchronous sequence in C# vNext. And there's very little code there to deal with all the mess. It's all just hidden away, and it just works. And I kind of like that kind of thing. So let's go back to the slides. Oh, one other thing because we're using metaprogramming and code first. Now we're not limited to C#. So if we wanted to, then we talk write in other languages routinely. So we could do the same thing in F#, for example. Or we could do the same thing in VB. And I think you'll agree, other than where things go, and the exact syntax, these all look very, very similar. But it kind of shows that and these all work. This is now kind of opening up gRPC, not just to C#, which is what we get with .NET Core 3, but to .NET. So it's now any .NET languages would be able to kind of use these features. And that's great. So let me go back to the slides. I know I'm getting a bit tight on time, but that's OK. So we looked at defining a server, creating a client. There's also tooling to generate the C# for you from a .proto. I didn't show that, but it's there. You can use other languages like VB and F#, and idiomatic, the current kind of features of C#, like asynchronous streams, the async iterator blocks. They work perfectly. And because we're avoiding gRPC core now, we can avoid shipping that kind of native binary at all. So in summary, gRPC, it's a great tool. It really is. Even the stuff today, the API doesn't excite me, but it would still be a really solid choice if you wanted to do something today. Bit of effort, but with .NET Core 3, Microsoft are fixing one half the problems, and I think if I can get this tool kind of shipped, that can fix the other half the problems. It is kind of tied into .NET Core 3 at the moment, though, because the async enumerable interface is kind of inherently tied into .NET Core 3. It is being made available to other, but it is being backported, but that's in an extension library. I think it's Microsoft.bcl.8 async. There's a library that you can just take a dependency on if you're targeting .NET Framework, and that will work. The demos I've got here, they work on .NET Framework and .NET Core 3. Other caveat here, everything I'm kind of showing here at the moment, if you download this code today, it probably won't work. You kind of need preview 7 bits, which is the dailies. It's all a bit brittle, and when I updated my desktop on Thursday, I can no longer do .NET Build. So yeah, be careful. I was glad I didn't update the laptop. That would have been fun. But if you're interested in this, you're interested in gRPC, either the Google way, or if you want to more interested in kind of the code first way, please come and talk to me or email me. I kind of love kind of talking about this stuff. And really, that's just it. Other than kind of thanks, and I hope that was useful and kind of get you kind of thinking about using gRPC rather than kind of writing this stuff yourself. So thank you. Now, I don't know if there's another talk directly after this or there's a break next. Which break? If there are any questions or if there's a break, then I'm probably not tied for time. If there are any questions or anything, everybody got it, then I'm more than happy to. Oh, there's one over here. Hang on. Hang on, one moment.
Is there
Is
there a fiddler kind of way to sniff what's going over the wire in gRPC?
Fiddler doesn't work with HTTP2, as far as I know. I tried it and it went horribly wrong. There may be networking tools to do it. You may need to drop the Wireshark, but also one of the problems is that because it's a binary protocol anyway, just HTTP2, plus you're then talking about binary payloads inside them, it may not be very obvious unless the tooling gets quite a bit better. So today, not as far as I know. If anybody here is aware of one, please send it, email me. I'd love to hear about it. But I'm not aware of a tool that will allow that today.
All right. Thanks.
Sorry? Okay. Okay, fair enough. I'm told that Wireshark will do the job for you. There you go.
Thanks.
Any other questions? It's like dodgeball. If you can dodge a wrench.
So do Protobuf and the tooling you just showed, do they also support abstracted types with interfaces and stuff?
I don't understand the question. Can you clarify?
So if I want to, with the async streaming you showed, if I wanted to stream events with different implementations.
Great question. Right. Now, Google Protobuf doesn't have a concept of inheritance. Protobuf Net does, though. What Protobuf, the Google version, does have is the concept of discriminated unions, although it calls them one-offs. So it's the one-of keyword. So you can have a response element that's got one of, a foo, a bar, a blap, one of 27 things that it could be. And Protobuf Net can implement one-ofs as inheritance. So you can have, and the way you do that, if I go back to a demo here, blah, blah, blah. Let's find C# because I can't do this in F#. So if I had a class, what I can do on there is proto contract. Using Protobuf, and then if you view proto include, and I'll say that field 1 is type of bar, and obviously that I think that would actually be it. That would be everything that would be involved. And if I had other things that implemented foo, then basically it would, from Protobufs, it would see that as a foo has a one of X, Y, Z. So there's a way of shimming over it, and if you just implement your class using the proto include syntax there, so obviously you might include, this is like XML include if you've done the same with XML serializer. You'd include all the 17 things that your type could be, and then you can generate the schema from that, and it'll show you what the proto would have looked like to do the exact same thing, and that works. Anyway, I'm being told I need to shut up. So I think I got that right.
Come on, man.
Thank you, Carl. Right, so thank you again.